Good morning. This is your stats sensei, Mr. Spensei, and on this assignment, we're going to run a confidence interval for a t distribution. All right, and the reason it's the t distribution is because we will not have the sample, that we will not have the population standard deviation. We'll have to use the sample standard deviation. So Mr. Spencer's statistics class noticed that Mr. Spencer appeared grumpier and more tired than usual, and that he was assigning copious amounts of statistics homework. The students know that Mr. Spencer enjoys one or more cans of Happy Juice every day. The Happy Juice distributor claims that each Happy Juice container contains 12 ounces of delicious Happy Juice. So this is the claim. Mr. Spencer's students collected a random sample of Happy Juice containers from a batch of over 1,000 and weighed the amount of Happy Juice to determine whether or not the distribution was putting less than 12 ounces in each can. So we're worried about less than and random sample. All right, we didn't have the sample size. All right, in each container. Construct a 99% confidence interval and explain the meaning of the confidence level. Well, the very first thing we have to do is define our parameter. So let mu equal the true population mean number of ounces of Happy Juice. All right. Conditions. Well, we have to have a random sample. Well, they told us it was random, right? They said that it was a random sample right here, but the question is of what size? Well, if I count them up, I count these up and I find out that I have 20, random sample of 20, and that was given. The next is um, the next thing is we need to know that whether or not it's less than 10% of the population. So n equals 20. All right, and we have 20 times 10 is 200. And our population size happens to be 1,000. So this is less than 1,000, so we're okay there. So our sample size is not greater than 20. I mean, not greater than or equal to 30. So it's not normal by central limit theorem. So they should have told us that it was normal, and I'm actually going to add that it is normal. So we're going to say normally distributed, and that was given. Even though it wasn't, I'm going to add that in. That's a mistake on my part. So normal distribution was given. Like I said, it doesn't say it here, but I'm going to make that adjustment. My equation is, and if they hadn't told us it was normal because our sample size is less than 30, we really couldn't do it. So t equals x bar minus mu s divided by the square root of, oops, excuse me, we're not running that. We're running a confidence interval. So x bar plus or minus t star s divided by square root of n. And now I need all that information, but I don't have it. So I need to go and take their data and go to stat edit and enter it all in. So there it is, 11.8, et cetera, et cetera. So I now have all the data entered in the calculator. So I'm going to go ahead and get that. And I'm going to go stat calc, one variable statistics, my list in L1, and then my frequency we can leave alone, and we calculate, and we go, okay, there's our X bar, 11.89. We know that our sample size is 20, and it also tells us on the calculator that it's 20. And our sample standard deviation is 0.1713, 0.1713. And our confidence level, we wanted to run a 95%. So the next thing we need to do is we need to calculate T star. Well, to do that, we're going to have to go to inverse T, and it's going to ask us for our area. We always have to do this, parenthesis, 1 minus our confidence level, 1 point, which is 1 minus the 0.95, that's our confidence level, divided by 2. It's also going to ask us for our degrees of freedom. Well, degrees of freedom is purely the sample size of 20 minus 1. So that's 19. That's easy. So let's go ahead and go there on our calculator. Second vars, inverse T, 1 minus 0.95, close parenthesis, divided by 2. And our degrees of freedom in this case is 20 minus 1. And we end up getting a 2.0930. Always keep T star positive. All right. And we're going to plug that in. So we're going to start plugging all that information into our equation, our X bar plus or minus T star. So X bar is 11.89 plus or minus 2.0930. Our sample standard deviation is 0.1713 over the square root of 20. So now I need to run this. So I'll go stat test. I'm going to drop down to number 8, which is my T interval. And I need to make sure data is highlighted. My list is an L1, so second followed by the number 1. And I needed to make sure my confidence level is 0.95. And there's my interval, 11.81 and 11.97. That's my interval. 11.81 followed by 11.97. 12 ounces isn't in there, so it's there. We're 95% sure that Mr. Spencer's getting less than 12 ounces. He's going to be grumpy. Please also notice that when we went there, we also got our X bar and our sample standard deviation. So some people could have just run this and got that information. All right, our conclusion. So what are we? Well, we are 95% confident that we have to restate this, the true population mean number of ounces of happy juice, that the true population mean number of ounces of happy juice per can lies within the interval 11.81 to 11.97. All right, now we have to explain the meaning of the confidence level. So, in repeated sampling, in other words, if we did this over and over again, we would expect this method to capture what? The true population mean number of ounces of happy juice per can. Of happy juice per can. How often do we expect it to capture it? We expect to capture it 95% of the time. I'm going to make one adjustment here. We should be saying per can up here as well, because that's how much happy juice. So there was one other question that says, we need to determine whether or not the distributor was putting less than 12 ounces. And it's like, we are 95% confident. So the distributor is putting less than 12 ounces in the can because 12 is not in the interval. And technically, I need to say that we're 95% confident that that's the case. I'm not, because I don't have enough room. All right. Appreciate you watching, and I hope to see you on the next one. Thank you.